Hello everyone, my name is Tong Liu. Today, I would like to present our demo, Correlation Graph Analytics for Stock Time Series Data. This work is sponsored by eSmart and TASMART project and funded by the Free University of Bolzano. To start, please let me introduce the context. So in database community, researchers analyze time series with the two well-known established branches. One is based on patterns like SAX, PAA. Another branch is study the frequency of time series, and then in particular, they use Fourier transform. However, little is known in the finance community. In finance community, researchers study the reason and the implication of stock crisis. And in particular, they use the correlation graph analytics for multivariate stock time series. They would calculate the minimum spanning tree from the correlation graph and investigate the changes of features of these obtained minimum spanning tree. With these features, and in particular, like the degree distribution, one can rely on that and notice the period of stock crisis. So this is the basic methodology. Given different time series, like in this case from A to E, first people will calculate the correlation matrix. Each value represents the correlation value between a pair of time series. For example, this point 0.97 is a correlation of time series A and B. After that, we will calculate the minimum spanning tree derived from this time series. But instead of a minimum value, we use the maximum value, and it will generate a sort of maximum spanning tree. This is a synthetic and a clear representation for the relation of each pair of time series. It's worth mentioning that most of the existing tools based on this theory are developed with adopt purposes. They are private, they are limited to specific functions, and they are not open to general time series data. So with this purpose, we propose our tool, which is a web application. It can be used by finance researchers as well as time series researchers. Furthermore, this tool offers a set of features based on the use cases of the finance community. First, it offers different view modalities, like comparison mode, where users can compare a minimum spanning tree of a normal period with a crisis period. In this way, they can understand the value differences and also the shape difference between the two. Evolving graph. Users can use it to see how a graph evolves along the timeline. Moreover, users can use different granularities, like weekly value or monthly value, as well as different parameter values to understand which are the best combination to make the tree stable and meaningful. Moreover, we offer different semantics, not only minimum spanning tree, but also the correlation graph can be visualized with our tool. And we also visualize the graph of classes, in this case in particular, like stock sectors. Now let's move to our demo. On the right side, you see a minimum spanning tree of an ordinary period. On the right side, you see a minimum spanning tree of the crisis period caused by the COVID lockdown. You can select different periods by using this sliding bar. And you can also inspect minimum spanning tree by zooming in and see the trading company names, the correlation value, and also the indicator, eccentricity score, and the stock sector. As we can see here, especially with the degrees distribution, is that the MST in the crisis period has a sharper degree distribution compared to other one. This is one of the most important economic theory that has been proposed in recent years. Other stock indicators are shown here in different tables, like number of ages, range of age weights, radius value, and the modularity score. Just to see how versatile this tool is, we can use that nodes represent classes to change the graph into a minimum spanning tree for stock sectors. Now let's check the next functionality, which is a evolving graph. Here we can fix the window length, which represent this kind of sliding bar, and also step size. We can choose, for example, 3 months as a window length and a step size as 1 month, 22 for the working days, for example, and compute the correlation graph. Next, we can use these 2 buttons, one to move forward and one to move backward. We use a solid age to represent the age which was also in the last picture, and the dashed one to represent newly added ages. The indicators and degree distributions are reported as well below. Besides this modality, we can also check the correlation graphs instead of MST. And this is a correlation graph. Okay. Let's move to the COVID period. And interestingly, we may notice is that when we enter the COVID period, these nodes connect together, and also the correlation value increased sharply. At this point, a user may ask, so degree distribution can be used to signal market crisis. What if I use different time window? Are there any impact for this? So this takes me to the third modality, which is the heat map. For now, this is only for demonstration because the computation of this is fairly expensive, and we leave it as a future work. In this modality, for example, we can use the first degree score to represent the sharpness of degree distribution. X means the starting point, while Y means the window length. Here, interestingly, marks the first degree score of these windows in market crisis. We can retrospect check the minimum span tree of a specific point by clicking on the element in heat map. With this kind of information, we can understand if a metric is reliable. For example, this one, first degree score, which refers to first degree distribution, is reliable because when the window enters in a market crisis period, the color change abruptly. And also this gives us another information is the condition to use this kind of a metric. For example, it is suggested to use higher number of time points. In this way, there's more contrast here. Similarly, we have the modularity score and the radius value. Radius value somehow shows the same information as the first degree score. As we can also notice that this part has a stronger period that covers the market crisis. So that was the demo part. In conclusion, in this work, we propose a web application for correlation graph-based time series analytics. As user are only required to upload the CSV file, and all the rest of the work will be done with our system. Our system enables this kind of extensive analysis with the different parameter values, different kind of representation, and different viewing modalities. As future work, we are investigating efficient methods for graph computations. Also, we are interested in automatic detection of relevant parameters, in particular to signal market crisis. That's all of this work. Thanks for your attention.